In this video, we will be talking about the signals which are greater than 1 bit. We will learn how to declare those signals in VHDL and how to assign values into them. Let's have a look into the example first. So we have a module with one input D in, which is single bit, and one output D out, which is vector and having 4 bits. So we return our entity like entity, my design is port D in colon in bit semicolon D out colon out bit vector bracket 3 down to 0 bracket closed semicolon and my design semicolon. Here D out is our bit vector, which means D out contains more than one bit or more than one signal, you can say. 3 down to 0 tells about the number of individual signals that D out can have. So if you split D out in single bit or individual signal, you will have D out 3, D out 2, D out 1 and D out 0, and that you can use in different ways in your VHDL design, which we will learn in some time. Let's start our architecture now, but before that, understand what we wanted to get from our digital system. Suppose our requirement is that when the input signal D in is 0, then all the output signals are 1. Remember, we have one output D out, and we are saying that all the output signals will be 1 because the output D out is vector type and it has 4 bits or 4 signals. So our output will be 1 in all 4 individual bits of this output D out. And if D in is 1, then all our output bit or output signals will be 0. Simple, right? Let's write the architecture then. Write architecture behavior of my design is begin process D in begin. If D in equals to 0, then output D out gets the value of 1 1 1 1 semicolon. Else D out gets a value of 0 0 0 0 semicolon. And if and process and architecture. So if you noticed in D out we moved 1 1 1 1 or 0 0 0 0 because D out is vector type and 4 bit long. So we moved 4 bits into D out. Also you must notice that we write 0 0 0 0 or 1 1 1 1 inside the double quotes, but when we check D in inside condition, then the value is within single quotes like here. This is because whenever you are writing anything for a single bit, this can be the assignment of data or conditional check like here we did for if statement, then that single bit always written inside the single quotes. But when you are writing anything for vector data types, means for more than one bit, then you need to use double quotes for that. Remember this, that single quotes or double quotes only be used when you are specifying the value of signal. Like here for D in we can use 0 or 1. For D out we can use any value from 0 0 0 0 to 1 1 1 1. In software languages we also refer this vector as array and its individual bit or set of bits called index of array. Like we can say that D out is array of bit data type and it is 4 bit long, and indexes are D out 3, D out 2, D out 1 and D out 0. You must need to understand how you can use these vectors in your designs and application. So in this slide I am telling you how you can assign any value into the bit vector D out. Look over the bottom section. In first example, we written D out gets a value of 0 1 0 1. Note that we use double quotes because it has more than one indexes. Because D out is a vector in which indexing is 3 down to 0, so first assignment will be in D out index 3, which is 0. Next, D out index 2 will get value 1, then D out index 1 will get 0, and last D out index 0 will get value 1. In second example, we assign data to individual indexes of D out. So we split D out indexes and mention the index in the bracket. So we write dout bracket 3 gets the value of 0. Similarly, dout index 2 gets the value of 1, dout index 1 gets the value of 0, and dout index 0 gets the value of 1. If you noticed, we use single quotation symbol here because we are moving single bit into the specific index of dout. Now look into the third example in which we moved value 0 to dout index 3 and then moved 1 into dout index 2. But now in the third statement we use 2 bits and written dout 1 down to 0 gets the value of 0, 1. That means dout index 1 gets the value of first assignment, which is 0, and dout index 0 gets second assignment. So first two statements are in single quotation symbol and the last statement is in double quotation symbol. Interesting thing is this, that all three examples assigning 0, 1, 0, 1 into dout, and index starts from 3 down to 0, but you just written them in three different ways. Another important thing to note is that you must follow the size of signal while assigning the data. Any mismatch in indexing size will result as a compilation error. Let's understand this with the example. Example 1 is correct because dout has 4 bits and we are assigning 4 bits in dout. Example 2 is also correct because we split dout in separate index by using brackets and assigned single bit data in each index separately. Example 3 is also correct because first two statements assigning single bit data on a specific index of dout and third statement assigning 2-bit data into dout to indexes. But example 4 is incorrect because dout has the length of 4 bits but we are assigning only 2 bits. Example 5, dout gets a value of naught of din. Again, this is incorrect because dout has length of 4 bits but din has length of 2 bits. Example 6, dout index 1 down to 0 gets the value of din. This is correct because we split dout length to 2 by indexing 1 down to 0 and din is also 2-bit long, so this is correct. Let me clear the markers in the screen. Okay, important thing to note here that when you are assigning any values, we used single quotes or double quotes based on the length of assignments. But did you notice that when we assign NOT gate of din to dout, we didn't use single quotes or double quotes in din. So this is important aspect to remember that single quotes or double quotes will only used when you are assigning any value of bit, but not with the signal name. Okay, enough examples. Hope I make vectors and indexing clear to you. If yes, please let me know from the comment section. In the next slide, we understand indexing little more. So let's move on. Note that the terminology involved with vector data type, which have left index mentioned and the right index mentioned, and the direction is also mentioned. Like here, we said 3 down to 0. That means our vector starts from the left index, that is 3, and will go down to 0, which is right index. You can also declare vector in ascending order, where leftmost will be your lower index and the rightmost will be your higher index. So whenever you are declaring indexes in descending order, you will use down to, and whenever you are doing it in ascending order, you will use to, as you see in both the examples in the screen. But in general, while declaring the vector, we prefer to use higher index in left and lower index in right, and so direction will be down to. This is because we want MSB to have our higher indexing and LSB to have our lower indexing. Let's understand this with a quick example. So first entity used dout, which is vector 3 down to 0. And second entity used vector dout, which is 0 to 3. Now we are assigning value 0, 1, 0, 1 in both the cases. In the first entity in top, assignment started from the indexing 3. So dout index 3 gets a value 0. And then dout index 2 gets value 1. Then dout index 1 gets 0. And last dout index 0 gets value 1. But in the second entity in the bottom, dout index 0 gets the first bit assignment, which is 0. And dout index 1 gets second assignment, which is 1. Similarly, dout index 2 gets 0 and the last index 3 gets value 1. As I said, VHDL compiler is very strict to the assignment terminology. So if by mistake, if you had mismatch indexing or sizes of vector, then VHDL compiler will tell you that you made a mistake and you can correct those things easily. Note that we are only talking about the mismatch size of bit or bit vector. Like for example, if you write dout gets a value of 100, then you will get the compilation error because the length of dout is 4 bits, but you only assigned 3 bits here, so it's a mismatch. So correct will be dout gets a value of 1100. You need to enter 4 bits here in this example. Now suppose by mistake you entered dout gets a value of 1010 instead of dout gets a value of 0101. Then what? Well, this is not the compilation error, so it will be compiled successfully, but you will not get the expected results in the simulation because it's a logical error and logical errors needs to be found by designers. Similar mistakes can happen when you are assigning part of one signal vector to some part of another signal vector. You need to ensure that right mapping of indexes or right assignment on the indexing. Here we will quickly talk on important things to remember about vector. Most important thing is that while assignment, signal type and signal sizes must match, VHDL won't allow you to simulate wrong vector size assignments and will give you the compilation error. You should ensure the right mapping of indexing while assignment for good results. Wrong index assignments means wrong results. Assigning single bit values will be in single quotes and more than one bit values needs to be inside double quotes. If you found this video helpful, please give it a like and leave a comment below, and don't forget to subscribe for regular updates.